This quick guide video provides an overview of the percentile analysis function and how it is displayed in the Affinity and Callisto software. As hearing aids have advanced, so have the methods required to verify them. The stimuli mostly used to obtain real ear measurements are shaped according to the long-term average speech spectrum. The intensity of this long-term average speech spectrum has complex properties in both the time and frequency domain. The percentile analysis is a standardized method of evaluating these properties of both the presented stimulus as well as the provided response at the eardrum. As a first step to understanding the percentile analysis, it is perhaps worth mentioning that the response curve that is usually compared to a prescriptive target represents the average intensities of a measurement. The percentile analysis shows something quite different. It shows a range of intensities for which 99% of the time the intensity stayed below the maximum of this range, and 30% of the time the intensity was lower than the minimum of this range. Perhaps this becomes clearer by explaining how percentile analysis is calculated. Let's find the label of the current measurement and right-click it. Then I select Detailed Percentile Analysis, and the first graph I like to show is the one with intensity as a function of time. Here we can see all intensity samples for the selected frequency as a function of time. To determine the different percentiles, all these samples need to be sorted according to their size. The graph showing all intensity samples sorted by intensity shows how these are ranked from lowest to highest intensity. At the x-axis, we can now find where we have passed the lowest 30%, and the corresponding intensity at 30% gives us the 30th percentile. Following the standard, we do the same for the 65th percentile and for the 99th percentile. These three values are plotted around the curve of the aided response graph, and the area in between we have highlighted to emphasize the dynamic range of the measurement. Note that the percentile analysis is performed on both the stimulus presented to the ear in the left graph and on the recording obtained at the eardrum in the right graph. This allows for mapping the original speech or any stimulus spectrum into the dynamic range that is available for the current patient. Notice that in the protocol settings you can choose to divert from the standardized method. For example, not everyone is interested to see the 65th percentile. This is because it does not have a relation to the average frequency response curve and can lead to some confusion. Others choose to use the percentile analysis not on the complete measurement but on a shorter time period which changes while the measurement proceeds. The latter is particularly favoured by those who like to show changes over time when listening to live voice or a music fragment. This concludes this quick guide video on understanding percentile analysis.